We're picking up with where we left off because our previous video was getting awfully long. So we have here the final problem where a professor is assigning 12 problems. Only 5 of them are going to be graded. And so we need to find out how many different groups of 5 problems can be chosen. The wording of this problem is not making it absolutely clear what we're kind of going for. But based on the other parts of the problem, what we're actually going for is a permutation. We're going to do 12, pick 5. In a lot of cases, when you're doing probability that's combined with permutations and combinations, often you're going to have a permutation to figure out the probability. So if you do 12, pick 5, let's go ahead and get our calculator up here. So we're going to do 12, math, go over here. And we're going to have 12, pick 5. That's 95,040. So that's what this is, 95,040. All right. So then a student's going to take their chances and only do 5 of the problems. So what is the chance that they have picked the exact 5 that the professor is going to pick? Well, this is basically going to be 5, pick 5 over 12, pick 5. So basically the student has picked the exact same 5 problems that the professor has picked. And the reason for this, if you write it out the long way, this is, there's a 5 in 12 chance that they pick the first problem. There is a 4 out of 11 chance that they pick the second problem correctly, because they are picking 4 problems left and there are 11 left to choose from. And then this is going to be 3 out of 10. That's going to be 2 out of 9. And then last, you're going to have 1 out of 8. So 5 pick 5 is equivalent to 5 times 4 times 3 times 2 times 1. 12 pick 5 is going to be the same as 12 times 11 times 10 times 9 times 8. So like if we do that, 12 times 11 times 10 times 9 times 8, and we get, as you can see, we get the exact same number. So what we need to do is find out what 5 pick 5 is. So 5 pick 5 is 120, which, by the way, is 5 times 4 times 3 times 2 times 1. That's also 120. So as I said, kind of a shorthand way of writing all of this is to do 5 pick 5 over 12 pick 5. So then if you're going to do that, the probability is 120 out of 95,040. That is not very good odds. That is 0.0013 if you round it off. 0.0013. So that's like a 1.3%, or no, a 0.13% chance that you correctly pick the 5 problems that the professor is going to pick. So those are not very good odds. So say the student is instead going to do 7 of the problems. So then what we're going to do is we're going to do 7 pick 5. So 7 times 6 times 5 times 4 times 3. And we only have 5 numbers this time. So we're going to do 7 pick 5 over 12 pick 5. So again, 12 pick 5 is 95,040. And then we need to find 7 pick 5. So 7, math, Go over to probability, do permutations, 7 pick 5. That is 2520. Let's see, so this is 2520. And so now we need to see what the odds are that the student will have correctly chosen the 5 that are actually going to get graded. So that's 2520 divided by 95,040. That is like a 0.0265. That's like a 2.5% chance. That's a little bit better, but not by a lot. What is that? 0.0265. Okay, so still quite unlikely. So when it comes to the last part of this, they say, how many problems would a student have to work to guarantee at least a 50% chance of working the 5 problems which will actually be graded? Okay, well, let's take a look here. So the pattern has been, if we did 7, it was 7 pick 5. When we did 5, it was 5 pick 5. And then the denominator is always 12 pick 5. Here's what we can do. We can go to the y equals menu and we can type in the following function. X, then do math and go over to probability where permutations are. So we can do x pick 5 for the first number and then divide 12 pick 5 for the last number, for the number we're going to divide by. Now it's showing here that I'm going to have error messages because graphing this is not going to go so well. But what I can do is I can go to second. Actually, let's see. Let's get out of this first. So go ahead and hit enter. All right, and then we're going to go to second graph to see the table. And so these numbers should look familiar. This is the 0.0013 that I got for only doing 5 problems. For only doing 7 problems, we have 0.0265. And if we want to guarantee better than a 50% chance, look at this. We have to go all the way up to 11 problems to get 0.58, a 58% chance. If you only do 10, you're only going to be sitting at a 32% chance of having picked all 5 that are actually for a grade. So in order to get your odds above 50%, you got to do 11 out of those 12 problems. It's almost like the professor in question is like a math professor and knows how to keep you all honest and actually have you do the work while he can get away with not grading absolutely everything. And you notice that if you do all 12, you get 100%, which, you know, because by then you're guaranteed to have picked everything that the professor did. So the answer to this one is going to be 11, and that's coming from the calculator. If you do 11 pick 5 and divide that by 12 pick 5, you will have a 0.58% chance, which is 58%. So you have to do a minimum of 11 problems to get above 50%. So with that, since there's only like a finite number, like you'll either do, you know, we already found up to 7 and that's really low. So like, you know, you could try 8, you could try 9, 10, all the way up to 11. There's only a limited number of possible things to check there. And so that would be the situation that meets those criteria. So that's the final little, shall we say, addendum to Chapter 5 there. And so we have now seen anything and everything you could possibly want to know about probability. Well, there's still more probability, but that's all for this chapter anyway.